because every business wants to maximize profit or maximize the revenue. Most of the times it's the revenue that you get, and in this case, it's when people are paying for tickets or buying things. So people buy it at a certain price, but if they increase the price, they'll usually get less people that buy that item. And if they decrease the price, you usually get more people that buy it. So in this example, we have 1,200 people that can be seated in this auditorium, and it's been full. So that's good. But because it's full, this owner wants to take the cost of the tickets at $5 and wants to increase it. So he's kind of guessing that if you increase it 50 cents, then you're going to get 100 people that are going to not come now. So they want to know what ticket price will maximize profit. So there's two methods that you can do this. So profit is always the people coming and times the price of the tickets. That's how much you're going to get. So the first way you can do it is you can always make a table. So you can say price, people, and then profit and revenue. So in this case, if the price is $5 and you have 1,200 people, you're making $6,000 every night. But if you increase it, so let's say you increase it 50 cents, so now the price is $5.50. Now only 1,100 people will show up, and that will only get you $6,050. So now you're making $50 more than this. But if you increase it another time to $6, only 1,000 people come, so you're back to that 6,000 revenue or profit. And if you increase it even more, less people come, which means you're making actually less money. So you notice that this row right here, this price at $5.50 actually maximizes the profit. So that's the price that they should keep it. So you can use a table for this if it's a simplistic version like this, but most of the time you actually have to use quadratic function to do this. So to do that, you have to create two parentheses. So you always say, what's my start value? And then you add or subtract, and whatever it's changing to times an x. Now the x in this case is like the amount of changes that you're going to make. So in this case, x is the amount of changes to the price of the ticket that the auditorium makes. So I can do price times people. These are going to be two parentheses. So the price starts at $5 here, and then I increase it, which means it's a plus, 50 cents every time. So that 0.5 is the 50 cents every time. X is the amount of changes I'm making. The people, I start at the 1,200, which means that's my start value, but now I'm going fewer, which is the subtracting 100 people for every change I make. Now what I do is I have to distribute or multiply these two expressions. There's a way I could do FOIL, which is I'm basically taking the 5 and I'm distributing into the second number, or the 0.5 times the second parentheses. Or you can use what I call the box method, where you create almost like a table. And you take your two parentheses, so I have the 5 plus the 0.5x, and I have the 1,200 minus the 100x. And I create a box out of it. And now I multiply individuals. So I would do the 5 times the 1,200, which would get me 6,000. I would do the 0.5 times the 1,200, which would get me 600x. Remember, the x stays with it. I would do the 5 times the negative 100x, so I would get negative 500x. And the 0.5 times the negative 100x. Remember, x times x leads to an x squared. So I get negative 50 times x squared. Now I can write my expression for this, combining my middle terms. These are my only terms here that are the same, are the x's. So I'm going to take this negative 50 here, x squared, that's going to be my a value. I combine these middles, so 600x minus 500x is 100x, and then plus the 6,000. I now have an equation that now I can identify my A, B, and C, find my axis of symmetry. In this case, it comes out 1. That 1 represents the amount of changes in price. So in this case, it's changing 50 cents. So I need to change that 50 cents one time. So if I started at $5, I make one change in the price, which makes it $5.50. So that's how I find the price. But like in other examples, I take that x, which is the amount of changes, and I plug it into my equation, and I solve. So when I plug in my equation and solve, I get that 6,050. And that is where I find my maximum revenue that I'm going to make. So in this case, by increasing it one time, I would make a maximum revenue of $6,050. So that's how I do it with a quadratic function. Now, this one was easy with the table to tell, but oftentimes it's multiple changes that I'm making. So you don't want to use a table all the time. You want to use a quadratic function that I can easily just find the maximum using some math. These are the 3 practice problems. Please try these. The first 2 are finding the vertex and determining if it's a maximum and minimum. And the second one is that word problem where you actually have to define the function and find how many changes you need to make.